Hi everyone, this video is a short video to show you how to using this method to find the volume of an object upon revolving over a horizontal line. So let's look into this example. Now here is the line with the equation y equal to square root x. Okay, for the location over here, the shaded part here is going to be the bounded region. Now you imagine this shaded part, okay, or the boundary region over here are going to revolve over the line at x-axis. Again, the shaded part here are going to revolve over the line x-axis over here. Now, the meaning of revolving over the x-axis is also equal to revolving over the line y equal to 0. They are actually having the same meaning over here. Now, what I will do is I will try to imagine this shaded part over here are going to revolve, revolve, okay, over the axis. When it's revolving, just like the fence, okay, our ceiling fence is going to revolve. Eventually, it's going to form a three-dimensional solid over here, okay. It's just like the mirror image, and eventually, upon the revolving, it forms a three-dimensional solid over here. Now, how we are going to find the volume of this three-dimensional shape object? We are going to using this method to find the volume of it. Okay, now the diagram in the right hand side here is going to be the shape of a disc. Okay, you can see this one is a disc with the radius. Okay, and of course the disc here having a certain thickness here. Okay, now I'm going to cut. Okay, I'm going to cut the 3D object here into a small disc. Okay, I'm going to cut it. Okay, cut it into a small disc over here. All right, so this will be the dish of the object here. Now, how I'm going to find the volume of the disc? The discs are going to have the radius here to here is going to be the radius of the disc, which is equal to r. And we know in order to find the volume of this disc, okay, the volume of one disc, okay, is always equal to pi r square dx, whereby the thickness over here is called the dx here. So pi r square dx is going to be the volume for one disc. Okay. Now, if let's say in this diagram, we are going to have a lot of discs over here. Okay, it can be further cut into 1,000, 1,000,000 pieces of discs here. So eventually, in order to add up the volume of all the discs here, we are going to using integration. So the volume of the whole 3D object is going to be integration from 0 to 4 pi r square dx. Okay, again, this location is the volume for one disc. However, we are going to have a lot of discs over here, so we use the integration to add up the volume for all the discs here. Okay, now what should be the radius here? If based on this diagram, the radius will be from the center of the disc up to the surface of the disc over here. So if you go back into here, the disc radius is going to be from here up to here. Okay, from here up to here. So since it's already touching the line of the equation, we are going to using the equation as the radius of the disc here. And the equation is going to be square root x over here, dx. Okay, of course we are going to put in the x inside the equation since this one is over the dx for the integration. Now we are going to continue with the integration. The rest is just the normal integration. Okay, 2 dx. So upon the integration, it's going to get so this is going to be the answer for the volume. Okay, 8 pi unit to the power of 3, is the volume for the object here. Alright, now in the second example, the shaded part over here are going to revolve over the line y equal to 1. Now how we are going to do this? The same thing, in order to revolve over the line y equal to 1, we are going to draw a line at y equal to 1, which is the red color line over here. Then you need to imagine the shaded part here are going to revolve over the line here. So normally what I will do is I will just imagine is revolve, revolve, revolve. Just like the fan again, just like the ceiling fan in our house are going to revolve, revolve, revolve. Okay, and eventually you are going to form something like this. This will be the mirror image. Okay, are going to form a three-dimensional object over here. Now, in order to find the volume of this object, again, we are going to using the well-known this method over here. Okay, so we are going to cut this object into a small disc over here. Okay, going to cut it into a small disc over here. Okay, let me take out the disc over here. Okay, now based on this one, the radius of the disc is going to be from here to here. This will be the radius for the disc. For the thickness for the disc is going to be from here to here. The thickness for the disc over here. We know the volume for one disc, okay, is always equal to pi r square dx over here. Okay, however, since they are going to have a lot of discs over here, there's going to have a lot of discs over here. So in order to add up the volume of all the discs here, we are going to using integration. So the volume for this object is going to be integration pi r square dx. While the integration limit is going to be from 1 to 4 here. Okay, 1 to 4 here. The region where the part is shaded. Okay, 1 to 4 over here. Now, how about the radius? Okay, we are going to discuss about the radius here. If based on this diagram, we know r is the radius is from here, this location to this location. So it's exactly from this line up to this line. Again, it's going to be from this line up to this line. And we know from here to here, okay, the whole line over here is exactly equal to the equation. While this part to this part here is equal to 1, okay, is equal to 1. That's the reason the radius here is equal to the equation. This whole thing minus 1 over here. Again, the radius of this location is going to be this whole thing minus 1. So it's equal to the equation minus 1 over here. Okay, and the rest is just about continue doing the same integration calculation. So let us continue. 1 to 4 pi. Well, this location you can actually doing the expansion. You're going to get x minus 2 square root x plus 1 dx. Okay, and upon doing the integration, you're going to get pi x squared over 2 minus 2x3 over 2 over 3 over 2 plus x from the integration limit 1 to 4 over here. Okay, by substituting 4 into all the x equation here, you actually will get 4 over 3 pi, okay, minus, after you substitute 1 into the equation, you're going to get 1 over 6 pi, okay, and the final answer is going to be equal to 7 over 6 pi, of course, with the unit to the power of 3, since this one is a volume. Alright, so hopefully this tutorial, hope you enjoyed this video, and I will see you in the next video. Bye bye. Don't forget to subscribe.